Dear students, in this video we discuss different types of relations defined on a set. First of all, the definition. You got a definition in your first day classes. What is a relation on a set? A relation which is denoted by R on a set A is a subset of the Cartesian product of the set A, that is A cross A. So since phi is a subset of every set, therefore phi is called a relation. It is called the empty relation on the set A. Similarly, we know that every element or every set is a subset of itself. Therefore, A cross B is a subset of A cross B. So which will be called the universal relation, which was discussed in first day classes. There is one more relation, particular type of relation is identity relation. If A is a non-empty set, the relation which relates every element of A to itself is called the identity relation on the set A. Okay, to the main topic, that is types of relations. Basically, there are three types of relations. The first one is called the reflexive relation. See, a relation R on a set A is called a reflexive relation if every element of the set A relates to itself. Just like every element of A must relate to itself, then only it will be called a reflexive relation. So we have an example of this. Consider the set Z of integers, and a relation R is defined on the set of integers as AB, means A relates to B if and only if A is less than or equal to B. Means an integer will relate to another integer if and only if it is less than or equal to that integer. We can see that every integer is less than or equal to itself. The equality exists. Just like 1 is less than or equal to 1, 2 is less than or equal to 2, etc. Therefore, we see that every integer, every element of Z relates to itself. Hence, R is a reflexive relation. In this particular relation, we see that it is reflexive. The next one is called the symmetric relation. A relation R on a set A is called a symmetric relation if A relates to B, implies B relates to A. Means if A is related to an element B, then B must also be related to A. So consider an example of the relation defined on the set L of all straight lines on a plane. Let L be the set of all straight lines on a plane, and let R be the relation defined on the set LB in this way. L1, L2 means L1 relates to L2 if and only if L1 is parallel to L2. Means a line relates to another line if they are parallel to each other. Okay, now you see, if a line L1 is parallel to a line L2, then conversely L2 must also be parallel to L1. That's what we get, that if L1 is related to L2, then L2 must also be related to L1. So that means it is in converse. Hence R must be a symmetric relation. Okay. A transitive relation, the third type of relation is called transitive relation. A relation R on a set A is called a transitive relation if suppose A relates to B and B relates to C. That means A must relate to C, then only R will be called a transitive relation. we have got an example like this. The very first one we already discussed this particular example to be a reflexive relation, which is A relates to B if A is less than or equal to B. Now we can see, so it will be transitive. How can it be transitive? See the example. We verify it with considering 3 integers 2, 3 and 4. Now we see that 2 is less than or equal to 3. That means 2 relates to 3. 2, 3 belongs to R. And also 3 is less than or equal to 4. That will mean that 3 is related to 4. But also we see that 2 is less than or equal to 4. And that will mean that 2 is related to 4. Now what we notice? 2, 3 belongs to R. 3, 4 belongs to R. And that will make 2, 4 belongs to R. So R must be a transitive relation. You can have more examples on this, but first one more definition I shall give it to you, and that is the equivalence relation. See, a relation R on a set A is called an equivalence relation if it is reflexive, symmetric and transitive. Means if a relation is having all the 3 properties of reflexivity, symmetricity and transitivity, then it will be called an equivalence relation. For example, consider the relation defined on the set of straight lines, where R is considered as L1, L2, means L1 is related to L2 if L1 is parallel to L2. Now how is it equivalence? We can see it here. Since every line can be considered parallel to itself, therefore it is reflexive. How can you consider it to be parallel? See the definition of parallelism. 2 lines are parallel if and only if the angle between them is 0 degree or 180 degree. We can consider a line to be parallel to itself because a line will make 0 degree with itself. Therefore, every line will be parallel to itself. Means every element of L will relate to itself, and that will mean that the relation is reflexive. Then comes the second one. It is already given in earlier examples. If a line L1 is parallel to L2, then conversely the L2 must be parallel to L1. So if L1 is parallel to L2, then L2 must be parallel to L1. Thus if L1 L2 belongs to R, then L2 L1 must also belong to R, and that will mean that it is symmetric. And for the third one, for transitivity, you see if a line L1 is parallel to the line L2, and suppose L2 is parallel to a third line L3, then L1 must be parallel to L3. Is it that? If one line is parallel to the second line, and the second line is parallel to a third line, then the first line must be parallel to the third line. That will mean that if L1 L2 belongs to R, and again L2 L3 belongs to R, then L1 L3 must belong to R. Okay, and this will give it that the relation is transitive. Since we have got the relation to be reflexive, the first one, the symmetric, the second one, and transitive, the third one, therefore that R is an equivalence relation.